Children, welcome to Whiteboard Bitoppers. Today we are going to start a new chapter, chemical bond. Now, first let us keep this word chemical aside and talk about bonding. What is bonding? Bonding in literal sense is a relationship, a close relationship. See children, we human beings are involved in several relationships: a father-child relationship, a relationship between two friends, a relationship among members of a community, etc., etc. Now children, what do these relationships provide? What do these relationships provide? They provide us a sense of well-being, a sense of stability, which can be emotional stability, social stability, financial stability, etc., etc. So basically, what do relationships provide? Relationships provide a sense of stability, or in other words, bonding provides a sense of stability. Just as we human beings are involved in relationships, so do atoms are also involved in relationships. And what do atoms get with these relationships or bonding? They also get stability. They also get stability. And why do atoms try to acquire this stability? Because as such, they are unstable. They are unstable. They cannot have independent existence. So they involve themselves in various relationships, and these relationships in which atoms are involved, we otherwise call them as chemical bonding. So chemical bonding is the relationships among atoms, and just as we human beings are involved in different types of relationships, so do atoms are also involved in different types of relationships, or in different types of bonding, or different types of chemical bonding. So in this chapter we will be discussing why atoms are unstable and how do atoms acquire this stability through chemical bonding. Then we will be discussing the various types of chemical bondings in which the atoms will be involved, and we will also be discussing the conditions that favor different types of chemical bonding. Hope children, you are clear with what all aspects we are going to discuss in this chapter. Now children, first we will preliminarily define what is a chemical bond. See, a chemical bond is the attractive force which holds any two constituent atoms or ions together. It is an attractive force. It is an attractive force which holds any two constituent atoms or ions together. Now, atoms are electrically neutral. Then, what is the attractive force between? Atoms are electrically neutral. Then, how do atoms of one element get attracted to atoms of another element? Children, that we will be seeing or we will be learning in the course of our discussion. Now children, the big question is, why do atoms combine? Why do atoms combine? See, I have given you a clue in my introductory part. Atoms combine to acquire stability. Atoms combine to acquire stability. Now, how is this stability achieved? How is this stability achieved? What is that an atom has to do to acquire this stability? The answer was provided by two scientists by name Cosell and Lewis. They modeled their argument based on the inertness of noble gases. They modeled their argument based on the inertness of noble gases. How noble gases come into the picture in order to explain the reason behind atoms combining, we'll be examining it in the slide to follow. Now children, so Lewis and Cosell independently explained the reason for formation of chemical bond based on the inertness of noble gases. Now children, I have written in the caption, inert gases, a beacon light. What is a beacon light? A beacon light is the one that shows direction. So the inertness of noble gases has shown the direction for Lewis and Cosell to explain the reason for the formation of chemical bond. Children, do atoms of all elements show this tendency to form chemical bond? Do atoms of all elements show the tendency to form chemical bond? Almost all the elements show the tendency to form chemical bond, with an exception of noble gases. With an exception of noble gases. Why noble gases do not show the tendency to form chemical bonds? See, the very word noble gases comes because of their inertness, because of their showing no tendency or to form chemical bond. They do not form chemical bond that easily. So what is that makes them inert? What is it that is responsible for their inertness? Children, now what is the reason for the inertness of noble gases? Now children, are you aware of valence electrons? What are valence electrons? Valence electrons are the electrons present in the outermost orbit, and it is these valence electrons that participate in bonding. Now, how many valence electrons do first period has? It has only 2 valence electrons. There is only one shell, and that can accommodate only 2 electrons. So what is the first period? What are the first period elements? Hydrogen and helium. So the outermost, or there is only one shell, so, and that shell is 1s shell, which can accommodate 2 electrons. Coming to the second period. Second period has 2 shells. First shell has 1s subshell, and the second shell has 2 subshells, 2s and 2p. So what are the maximum number of electrons that can be accommodated in the outermost shell, that is the second shell? It is 8 electrons. So as we move from second period to third period to fourth period, it is always 8 electrons in the outermost shell. So there will be only s and p subshells in the outermost shell. So if there are 8 electrons in the outermost shell, then the element will not show any tendency to react. So the noble gases have 8 electrons in their valence shell. So because of the 8 electrons, their requirement is fulfilled, and hence they do not show any urge to react or to participate in chemical bonding, because their stomach is full. They have no reason to participate in bonding, because the maximum number of electrons that can be accommodated in the valence shell is 8, and noble gases have 8 electrons in their valence shell. So there is no reason for them to react, or there is no reason for them to participate in chemical bonding. So any element that has 8 electrons in the valence shell will not show any tendency to participate in chemical bonding. And the 0 group elements or the 18 group elements, which are the noble gases, have 8 electrons in their valence shell. Therefore, they do not show any tendency to participate in chemical bonding. It is precisely this inertness of noble gases which prompted Cosell and Lewis to explain the reason behind the reactivity of other elements. Now, children, what is the criterion for stability? The criterion for stability or low energy is to have a completely filled valence shell, that is possession of an octet or duet. Children, what is the duet meant for? It is for elements with lower atomic number. For example, hydrogen, lithium, beryllium. These elements try to acquire the nearest noble gas configuration of helium, which has 2 electrons in the outermost shell. Remaining elements try to achieve the nearest noble gas configuration, that is by having 8 electrons in their outermost shell. So, the criterion for stability or low energy is to have a completely filled valence shell, that is possession of 8 electrons in the outermost shell. So, the possession of 2 electrons is only a small exception. It is only few elements near about helium that show a tendency to acquire the duet. Remaining elements show a tendency to acquire the octet through participation in chemical bond. So, the formation of chemical bond, as we have seen in the earlier discussion, can be explained in terms of valence electron, and this was what was done precisely by Cosell and Lewis. Cosell and Lewis developed an important theory of chemical bonding based on valence electron and is known as electronic theory of chemical bonding or octet rule. So, what do all these elements try to achieve through chemical bonding? They try to achieve a full valence shell. What is full valence shell? It is the presence of 8 electrons in the outermost shell. Now, so all the atoms except the atoms of noble gases show an urge to what? What, children? Show an urge to achieve 8 electrons in their valence shell. So, this urge to acquire a complete valence shell or present by having 8 electrons in the outermost shell is called octet rule. Octet rule is the rule that gives a reason for the chemical reactivity of atoms of various elements. Why do atoms participate in chemical bonding is nicely explained by this octet rule. According to octet rule, atoms prefer to have 8 electrons in their outermost orbit by losing or gaining or sharing electrons. So, it can be either by losing or by gaining or by sharing electrons, but nonetheless, the endeavor of each and every atom of each and every element will be to acquire the octet, whether it be by losing electrons, whether it be by gaining electrons or by sharing electrons. This is what is octet rule. Okay. Children, now we'll sum up the definition of chemical bond. Earlier we have defined in a rather raw manner. That means a chemical bond is an attractive force which holds the atoms or ions together. Now we'll give a little refined definition. A chemical bond is the attractive force that holds 2 atoms together or 2 ions together, wherein each atom tries to acquire the octet by losing, gaining or sharing electrons. So children, what have we done in this slide? We have defined chemical bond vis-a-vis octet rule. We have defined chemical bond vis-a-vis octet rule. So the endeavor of every atom will be to achieve the octet through chemical bond formation. Hope children you are clear with this, with the link between the chemical bond formation and the octet rule. Now children, chemical bond is a stabilizing phenomenon. Why it is a stabilizing phenomenon? Because it is always accompanied by the evolution of energy. A chemical bond formation between two atoms is invariably accompanied by the evolution of energy. Now children, you must be knowing, a system, if it has high energy, it is said to be unstable. So the lower the energy of the system, greater will be the stability. Now what is happening in chemical bond formation? It is invariably being accompanied by the evolution of energy. Therefore it is always a stabilizing phenomenon. A chemical bond formation is always a stabilizing phenomenon. Remember children, a chemical bond formation is always a stabilizing phenomenon. Why it is a stabilizing phenomenon? Because it is invariably accompanied by the evolution of energy. Two atoms before formation of a bond will be having higher energy individually, and when they combine to form a molecule, they will be giving out energy in the process of formation of chemical bond. So the molecule will be having lesser energy than the individual atoms. So a chemical bond formation is invariably accompanied by the evolution of energy. Therefore it is a stabilizing phenomenon. Now children, we have earlier defined chemical bonding as the force of attraction between constituent atoms or ions. Then I have underlined that the term attraction. See, I told you that atoms being electrically neutral, where is the attractive force coming from? Here in this slide we will explain the genesis of the attractive force. The attractive force children will be between the electrons of one atom and the nucleus of another. The attractive force will be between the electrons of one atom and the nucleus of another. And electrons of one atom means, what are those electrons children? They are the outermost electrons. In other words, it is the valence electrons. So the attractive forces that hold the atoms together during a chemical bond formation is the force of attraction between the nucleus of one atom and the valence electron of another. And children, along with attractive forces, there will also be repulsive forces. Guess where will the repulsive forces come from? It will be between the valence electrons of one atom and the valence electrons of another. And it can also be, the repulsive forces can also be between the nucleus of one atom and the nucleus of another. So there will be attractive forces as well as repulsive forces. Attractive forces are between the valence electrons of one atom and the nucleus of another, and repulsive forces will be between the nucleus of two atoms and the valence electrons of the two atoms. Now children, what do attractive forces do? Means, how do they influence the energy? Children, I think you should be knowing, attractive forces decrease the potential energy. Children, once again I am repeating, attractive forces decrease the potential energy or in other words, they increase the stability. Repulsive forces increase the potential energy. That means increase in repulsive forces will increase the potential energy, or in other words, increase in repulsive forces will decrease the stability of the system. Once again, I repeat, attractive forces, increase in attractive forces will decrease the potential energy of the system, thereby increasing the stability. Increase in repulsive forces will increase the potential energy of the system or decrease the stability. So watch these sentences very carefully and try to remember them. Attractive forces is always a positive influence. It will increase the stability of the system by decreasing the potential energy. And repulsive forces are unwanted forces in a sense, because they increase the potential energy of the system and therefore they decrease the stability. So increase in attractive forces decreases the potential energy and therefore increases the stability. Increase in repulsive forces will increase the potential energy of the system and decrease the stability. Now children, we will be showing you a video depicting how the potential energy plays out as the atoms approach one another to form a chemical bond. Children, here I am showing you the video of the potential energy. We'll see how the potential energy changes during bond formation. How the potential energy changes during bond formation. Here you are seeing two atoms, one represented by yellow color and the other represented by red color. See, now the red color atom is moving towards the yellow color atom to participate in bond formation. See, what is happening? As the red color atom is moving towards the yellow color atom, the potential energy is decreasing. Now what do you understand by this, children? Potential energy is decreasing means, what are the forces that are dominating here? It is the attractive forces that are dominating over the repulsive forces. And what are the attractive forces between? The attractive forces are between the electrons of the red atom and the nucleus of the yellow atom, and the electrons of the yellow atom and the nucleus of red atom. And what are the repulsive forces between? The repulsive forces are between the electrons of red atom and the electrons of yellow atom and the nuclei of the two atoms respectively. So now, as the atoms are approaching, the attractive forces, as long as the attractive forces dominate over the repulsive forces, the potential energy is decreasing. Now see, and at this distance, the potential energy has approached a minimum, and see what happens thereafter. The potential energy is continuously increasing. So in the first part of the curve, the attractive forces are dominant over the repulsive forces, and at the bottom of the curve, the magnitude of attractive forces are equal to the magnitude of repulsive forces, and then at a distance less than this, the repulsive forces start dominating, and the bottommost point where the repulsive forces are exactly equal to the attractive forces, the distance at that point between the two atoms is called the chemical bond. So, in other words, chemical bond is the internuclear distance between the two atoms where the magnitude of attractive forces is equal to the magnitude of repulsive forces. At a length greater than the bond length, attractive forces are more than the repulsive forces. At a distance less than the bond length, the repulsive forces are more than the attractive forces. So, at a distance greater than the bond length, attractive forces dominate. So, the potential energy is decreasing. And at a distance less than the bond length, the repulsive forces are dominating. Therefore, potential energy is increasing. And at the bottommost point where I am keeping the cursor, there the attractive forces is exactly equal to the repulsive forces. That distance between the atoms or between the nuclei of two atoms where the attractive forces are equal to the repulsive forces is called the bond length. Children, I hope you are clear with this diagram. See. So, that is the bond formation length where the attractive forces are equal in magnitude to the repulsive forces. Children, today we will now we will conclude this session, and before concluding I would like to summarize of what all we have discussed in this session. We have elaborately discussed what is a chemical bond. Then we have discussed the importance of noble gases in understanding the chemical bond. Then we have discussed the octet rule, and then we have seen how chemical bond formation is a stabilizing phenomenon, and we have explained it elaborately in terms of potential energy diagram. Hope children, all these concepts that we have discussed are clear to you. Okay children, I am concluding this session. Wish you good luck. Bye bye.